All right, here we go. Algebra. I'm going to try to go through this one just a hinge faster than the last one, although it actually is a little more difficult, I was noticing, so I, really hope you all work through this. All right, so let's start at the beginning. Remember that negative is perfectly fine right where it is. Don't care about the negative in the front. Leave it. Don't care. All right. The power is -3. That I care about. I can't have that. So I got to put that in the bottom. So I'm going to do 1 over 5 to the third. And 5 to the third is 5 times 5 times 5, which is 125. And the negative just hangs out. If this had been in parentheses, then I would have also raised that to the third. But it wasn't. So therefore, it doesn't get raised to the third. Number 2. I've got 3 things multiplied together. I've got a 4, an x to the 0, and a y to the -3. Before I move on, I see x to the 0 and want to get rid of that immediately, because that's 1. So I have 4 times 1 times y to the -3. 4 times 1 is 4 times y. Where's my y? Here it is. 2 to the -3. All right. Now I need to leave my 4 alone, because what's the power of the 4? It's a +1. There's absolutely nothing wrong with the 4. I don't want to move the 4. I only want to move the 2 because of that power that's a negative. So I'm going to make a fraction. The 4 is going to stay right where it is, but in order to make that power positive, I'm going to put it on the bottom. And I'm going to raise it to the third power, and I'm going to get 4/8. And before I get too quick to put that in a box, I'm going to simplify it and get a half, and now I'm going to box it. All right. Now, same thing with 3. What's raised to the -8, class? The b. That's it, not the 5. Okay, leave the 5 alone. It doesn't want to be messed with. Okay, so the 5 stays right where it's at. But in order to get that to be a +8, I need to move it downstairs. And we are done. All right, number 4, power of 10. Okay, I got to slide until I get the number 1. So I'm going to have 10 raised to something. Let's find out. 1, 2, 3, 4, 5, 6, and 7. 10 to the -7. It did not say write it as scientific notation. If you did, it would have been 1 times 10 to the -7. But it's just 10 to the -7. 5, write this as scientific notation. So now it's saying scientific notation. Up there it was power of 10. So I need to take this, my decimals here, and it's going to be something times 10 to the something. Let's see what we get. 1, 2, 3, 4, 5, and 6. Perfect, because my number is 6, which is 1, 2, 3, 4, 5, 6, 7, 8, or 9. So that works. And how many hops did I do? 1, I forgot already. 1, 2, 3, 4, 5, and 6. And it's +6, big number. If it was little small, then it's negative. That's how you can kind of remember that too. Right, this is standard form. Okay, I want to go backwards. This is scientific. I want to go back to standard. So I'm going to write the 8.5, and it's a -7, so I know it's going to get a lot smaller. So I'm going to move this decimal 7 spots to the left. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, 6. Rewrite it so it's very clear where my decimal is. All right. The first letter in today's lesson, so that I know you watched the whole video. The first letter is R. All right, we are 2 bases and we have multiplication, so what do we do with the powers? Add them, so it's y to the 7 plus 3, which is y to the 10th. This one is 1 base, and it's a power to a power. So I multiply there, and it is x to the 80th. I am still all about multiplying, okay, but I got to get rid of the parentheses first. So how many terms are in here? Remember, there's no adding or subtracting in here, so each one can get raised to the 3rd power. negative 3 to the third power. So I have a to the negative 3 to the third times b to the fourth to the third times a to the second to the fifth. Now they all kind of look alike. Let's just do it. When it's power to power, we multiply. A to the negative 9th times b to the 12th times a to the 10th. And lo and behold, we have two of the same base that are multiplied, so we will add the exponents, and we get a to the first times b to the 12th, which can also be written as a b to the 12th. All right. In 2000, the population of Defuniak Springs, Florida, was about 5,000 people. The population of the entire state of Florida was 3.2 times 10 to the third times larger than that population. Find the population in Florida. So I need to take my 5,000 and I'm going to multiply it by this many times. It said it was that many times bigger. So again, I want to move this to scientific notation, 5 times 10 to the third, so that I can combine like terms. 5 times 3.2 is 16, and times 10 to the two bases, add the powers, 10 to the 6th. This is not scientific notation. The decimals here, so slide over one spot. 1.6 times 10 to the 16 to 1.6 that got smaller, that gets bigger. 1.6 times 10 to the 7th. All right. Now we're moving on to number 11. Again, no adding and subtracting in here. So we first have to get rid of parentheses. So we have a to the 18th, b to the 6th over power to a power. That's a to the 12th, b to the 5th. So now when I have 18 a's on the top and 12 a's on the bottom, remember 12 of these will cancel. And I'm going to have 6 left. And where are they going to be? On the top. Very good. And I got 6 b's and 5 b's. So how many are going to have left? 1 on the top. So you don't have to put it over 1, but you could. Let's see, do we have that for an answer? We do. It's right there. All right, 12. When we get to 12, again, there's no adding or subtracting, but you need to look inside to see what is all being raised to the 5th power. So I've got an x, I've got a y, and I've got another x down here. So you could simplify this right now. That would be fine. Let's actually do that. That's on the inside. So if there's stuff on the inside that you can simplify, let's do it. So I still have the y to the 4th, but how many? Look, I got 2 x's in the top and 6 in the bottom. So how many left over will I have? 4. And where? In the bottom. So I can go ahead and do that and go back to the same thing, but I just simplified that inside a little bit, which is fine. Now I have y to the 4th to the 5th over x to the 4th to the 5th. They're both raised to the 5th power, power to a power. I multiply y to the 20th over x to the 20th, j. 13. What should go off? What sirens should be going off in your head? Deet, deet. We don't like those, do we? And there's fractions on the inside, and that's okay. We just have to take the reciprocal of them and make this a +1. That's it. And then we take the reciprocal of this one and make it +4. It literally doesn't go anywhere. You just take the negative out. So now, when I have 3 over a to the 2nd to the 1st power, well, that's just itself. That doesn't change anything. Here it's a little different because we have all of this to get raised to the 4th power. How many things are in there? Got a b, got a 3, and got an a to the 3rd. So I've got b to the 5th to the 4th over 3 to the 4th over a to the 3rd to the 4th. So I'm just going to rewrite this. So I have 3 over 8 to the second. I'm just going to do one big fraction because since I'm multiplying, I can do that. Power to a power means you multiply. 3 to the fourth. What is 3 to the fourth? 3 times 3 is 9, times 3 is 27, times 3 is... But wait, hold the phone. I'm going to leave that like that. Are you holding your phone? All right. 8 to the third to the fourth. Multiply 8 to the 12th. So let's simplify now. Before we multiply this 3 out, I see there's a 3 to the first right here. Okay, so we can simplify. One set of 3's will cancel out, and there'll be 3 left where? On the bottom. B's, there aren't any other B's. A's, I've got 2 A's on the bottom. So since they're on the same level, we just can add them. So I'm going to have a to the 14th. Now, 3 times 3 is 9, times 3 is 27. So there is my grand finale answer. Hopefully it's one that we have. Oh, there's not multiple choice. Let me see if it's right. Yep. So it's all good. 14. Remember what we said, this is a quotient, so write it as a quotient. So as a fraction, 1.2 times 10 to the negative third over 4 times 10 to the 7th. Because then you can go and then handle them each separately. So do 1.2 divided by 4. You get 0.3 times, remember we talked about this in the other video. And let's make this positive so that we can see what we have. Well, I mean, we can do, it's hard. You can do it either way. You can either move this up and combine it, you can move this down and combine it, or you can just remember that it's 10 to the negative 3 minus 7, which is 10 to the negative 10th. And it is scientific notation, so in scientific notation it is okay to have a negative, so let's just call that good right now. But we aren't in complete scientific notation. Why? Write that. Remember, the number before this has to be 1 to 9, and right now it's 0. So we got to shift this to the right so that we can get our 3. But the question becomes, that went from 0.3 to 3. So did they get bigger or smaller? Got bigger, so this should get smaller. So what do I do? Right, a negative becomes now a negative 11. It gets even smaller. And that is the answer. Where is it? Up here. Here we go. G. All right. Now we are going to look up here at these roots. We talked about how the top number is the power and the bottom one is the root. So right here, the power is 1. So that's pretty simple. There's nothing I need to do. But the root is the hard part. 125 minus the 6th root of 64. Now, we can use our calculators if you want, but they're not that hard to figure out, but I will show you. So on the bottom here is the 3rd root right here. So I'm going to do 3rd root. Well, actually, I'm sorry, on this calculator I put the 125 in first, and then 2nd and 3rd root, and it's 5. So typically, if they come out whole, they're going to be pretty small anyway, and 5 times 5 times 5 is 125. Now, the 6th root of 64, it's going to have to be kind of small. So let me see where my root is on here, the 6th root. Okay, it's up here, so right here. So 6th would be that top one, the X, and then that. So I'm sure I do 6, and then I'm going to push the 2nd, and then push 64, and that's definitely wrong. Okay. I could also do the power of X. Let me see if this works. 64, and then that, and then 2. No, let's try this. 64, and that, and 6. Oh, hallelujah, hallelujah, hallelujah. Ah, ah, ah. Okay, did you see what I just did? Let's try that again. So let's get this on the board here. So using this top one right here, I did 64, then I did the second, and that button, and then I put the root in, which was 6, and then push equal. There we go. Stephen, and who else was it that we were struggling with that? That's how we do it. You put in the root first. The inside part first, then the button, then the root. Okay, answer's 3. All right, got on to this one. The power is 4, the root is 3. Power, root. So we have the third root of 64 raised to the 4th power. Third root of 64. It's got to be pretty small, but we can try it here. Third root is down here. Okay, so I'm going to do 64 and my third root, and it is 4 to the 4th power. So I'm going to do 4 raised to the 4th power, 256. How else could I have done it? 4 times 4 times 4 times 4, but I didn't want to do that. So I did 4, just to show you again, raised to the 4th power. Okay, good. As I said, second letter for the word is E for the special word. All right. For this one, we're going to, remember, view this separately so that you don't get mixed up. So we're going to look at this first. Then we're going to look at this second. Okay, this is to the 3rd power. There's no adding or subtracting, so you can power to power. Power to power. So I have x to the 1/3 to the 3. Y to the 1 to the 3. And you're multiplying. We did this before in the last page. Third of 3 is 1. X to the 1. 1 times 3 is 3. So I got that part handled. This one, when there's no root here, what is that? It's a half. There's 2. So you can rewrite it with the halves, or you can remember the shortcut I showed you, which is the power divided by the root. Just like we said right here, power divided by the root. So 4 divided by 2 is x to the 2nd. 6 divided by 2 is y to the 3rd. These are all multiplied. So when we have bases that are the same, and we're multiplying, we add the powers. X to the 3rd. More bases that are the same, add the powers, y to the 6th. All right, so what is the leading coefficient of the polynomial? Well, first we got to get it in descending order. Highest power here is the x to the 5th. I'm going to make sure I take that good old negative with it. Then I'm going to add the 7x to the 2nd minus 9x plus the 4. The leading coefficient is not x, it's the number before it, a -1. Classify. The special word classify means tell me what the names are according to degree and terms. So the degree isn't the adding of them all. It's each one, we have to evaluate each one and see which one's the biggest. The degree here is 5. The degree here is 2. The degree here is 1. And the degree here is 0. What's the highest? 5. So we have, and after the 4th degree, it becomes, you just say the degree. So it's the 5th degree. And then the number of terms. 1, 2, 3, 4 terms. So we had 4 terms. And 5th degree. 4 terms is quintic. I'm not going to put that on the test. Just saying, quintic is so uncommon. That, yeah. No, the reality is having a binomial, trinomial, those are pretty common. And having a linear equation, which is a degree of 1, or a quadratic, which is a division of 2, or even a cubic, which is 3, those are all pretty common. So I'm guessing, I'm going to stick with that, but let me look because I don't want to lie. Just in case. Yes. Yes. It will be either cubic or below, and it will be either quadratic or below. So you need to know up to the first three of each. By memory. All right, one more page. Okay, remember what I said about these? They're showing you ways that things are used, that they use these quadratics in real life, but they really are giving you most of the information in it. You just substitute. Jamal throws a golf ball straight up from a height of 5 feet at a speed of 75 feet per second. The height of the ball is given by the polynomial. So see, they gave it to you. The height is given by this polynomial. The height is given by this polynomial. So although they just described all this information for you, they didn't expect you to put it into this. They did that for you. So don't let that throw you off. This information is right in the equation already. And t is the time in seconds. How high is the ball? How high is the ball after 4 seconds? Oh, they gave you t. It's 4. All you have to do is substitute it in. Okay, the negative's out front, so don't let that bother you. 4 squared, do that first. Powers first. 4 to the second is 16. 16 times 16 is 256, and it is definitely a negative. 75 times 4, make sure you do order of operations properly here. Okay, we do this, we do this, we do this, then we add them all together. Okay, so I have negative 256 plus 305, and that is what? 49, I think. Is that 49? Good, just making sure I'm adding right. Height is 49. What unit? Feet. All right, now we're going to add. Okay, so remember, adding and subtracting are different than multiplying, 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 multiplying. Okay, so don't mix them up. So when we add these, we have to distribute before it, but it's just a 1, a positive 1, and a positive 1, so it doesn't affect anything. So I can just rewrite these. Uh-oh, I hear the car. The car is home, and I suspect somebody will be blasting through the door in about 2 seconds, but let's hope not. All right, the next magical letter is G. All right. Like terms. Any other x to the thirds? Nope. We got negative 5x squared and positive 7x squared, so that is positive 2x squared. Oops, I should have highlighted these to help you guys. I don't know if you do that anymore or not, but I just want to make sure it's clear. And then negative 0.4 and 1.3 should be what? 0.9. All done. Now we get to subtracting. That's a different ball game. This one is a positive 1, so nothing changes. So I can just rewrite that one. The problem is here, it's a negative 1 and not a positive 1 like it was up there. So that changes everything inside to the opposite sign. So inside the parentheses I had a 7a squared. It is now a minus 7a squared. And inside the parentheses I had a minus 8a. It is now a positive 8a. I have 4 terms. We need to see if any are alike. I think we do. We've got that one, and I'm going to make sure I don't make a mistake and leave these negatives out. 10 minus 7 is 3a to the second. And then I have a 6a, and a negative 6a and a positive 8a, so I have a 2a. All done. Now we switch gears. We multiply. So here it's just straight up. This times this times this times this times this times this. It's all multiplied. Put the numbers together. Put the r's together. Put the s's together. So there's no special things with like terms when you're multiplying. So negative 5 times 3 is a negative 15. R to the first times R to the fifth. Add the exponents. R to the sixth. S to the fourth. S to the second. S to the sixth. Done. Got another one of these rectangles. So we're going to draw our little picture. It says the width is W, and the length is 4 units longer than 2 times the width, or, lovely, they give us the 2w plus 4. So you didn't even have to figure that out. That part they figured it out for you because they want to see if you can get the area and write it as a polynomial. So area is length times width. And again, I'm going to just put the width first because I like the smaller one in front. Times 2w plus 4. Did you put it in parentheses? You got to put it in parentheses because you need to distribute. W times 2w is 2w to the second because we add the exponents. And w times 4 is 4w. And we are done. All right, multiplying. 4 problems left, people. We can do this. We're going to use FOIL on this. First, outside, inside, last. So we're going to look at the first term of each parenthesis and multiply. 4x times 7x is 28. Add the exponents, x squared. Plus, outside, 4x times 4, 16x. Plus the inside, negative 5 times 7x is a negative 35x. And the last, negative 5 times 4 is a negative 20. Now when you look for like terms, you can see that you have 2 right there. So I have a 28x squared plus 16x minus 35x. What is that? That is minus 19x minus 20. Done. When we come to this one, this is that one I said, do not cube it. It is not like I wrote 2b to the third, and we can just raise them each to the power. We've got a subtraction in here. We can do that. Okay, new color. I have to rewrite it. 2b minus 1 times 2b minus 1 times 2b minus 1. I'm going to take the second 2 first because I like leaving this guy in the front all alone. I'm going to do FOIL. First, 2b times 2b is 4b to the second. 2b times negative 1 is negative 2b. Inside, negative 1 times 2b is a negative 2b. And last, negative 1 times negative 1 is a positive 1. I indeed have 2 like terms here, negative 2b and negative 2b, so I have 4b squared minus 4b plus 1. And I drop this guy down and repeat, except I can't really, I mean you can use FOIL in some sense, but I need to take and multiply this 2b by everything in here. So 2b times 4b to the second is 8. b to the third. 2b times a negative 4b is a negative 8. b to the second. 2b times 1 is 2b. Now we go to the inside. Negative 1 times 4b is a negative 4b squared. I'm sorry, negative 1 times negative 4b. I think I said negative 1 times 4b squared. There we go. I think I said that wrong. Negative 1 times negative 4b is a positive 4b. And negative 1 times positive 1 is a negative 1. Like terms, yes. Negative 8b squared and negative 4b squared. Because I don't have any other b to the third, so I've got a negative 12b squared. And I also have 2b and 4b. So that is 6b. And the minus 1. And let's verify I didn't make a mistake. I did not, and that is correct. Next one, same thing. We have adding in there, so we're not just raising it to the second power. I got to rewrite it. But I got to rewrite it with a different color because that is just too much purple on that. 5x plus 3y times 5x plus 3y. We're going to use FOIL. First term, 5x times 5x is 25x to the second. 5x times 3y is 15xy. And then we go to the inside. 3y times 5x is 15yx. To the last, 3y times 3y is 9y squared. Are there like terms? You bet, because xy is the same as yx. So I end up with 25x squared plus 30xy plus 9y squared. Or you could have noticed this is a perfect square trinomial, meaning 5 squared is 25x squared, 3y squared is 9y squared, and to get the middle term you multiply them, 15xy, and you double it, and it's a positive. But that takes a little bit of practice, so you can get it the long way right now until that becomes a little more familiar. Now, let us move ahead here, and this is another one that you could notice, but I'm going to first go through it the other way and grab some other color. Let's do orange. We're going to use foil. Be careful. 4p squared times 4p squared is 16p to the fourth, adding exponents. 4p squared times a negative 6q is a negative 24, p squared q. Now we go to inside. 6q plus times 4p squared, wow, I can't spit that out, is plus 24qp squared. And 6q times negative 6q is a negative 36q squared. Do we have like terms? We for sure do. We have these. Because the order doesn't matter. Whether it's p squared q or qp squared, they're the same variables to the same powers. And they're one's positive and one's negative. So they fall out, and I'm left with this. Which is a difference of squares. It's a difference of two perfect squares. The square root of this is 4p to the second. And the square root of this is 6q. Look at 4p to the second, 4p to the second. 6q, 6q, ones plus, ones minus. That is how a difference of squares will factor. Or if you notice the commonality where they're exactly the same except one's positive and one's negative, that is where these will get multiplied and these will get multiplied. It'll be a difference, which is subtraction, and the middle terms will always cross off. But again, this does take time to understand that. I'm just looking ahead. The next letter is G again. I'm trying to look to see the test, make sure I do not lead you astray. Yeah, so it is something similar to this. If you understand this, you will definitely understand the one from the test. This is probably a hinge more difficult. So the next letter is I. I did not tell you, we are almost done, except I didn't tell you my book for today, so I just want to show you quick. It was Stone Soup. If you ever never read it, read it to your little siblings. Stone Soup by Marcia Brown. The last letter is E. So you should have a word now that you can write up very small by your name, and I'll know. Oh, yes, I will, that you watched the video. Which I'll expect all of you to have done because you guys are all awesome and the best students ever. So anyway, have a great day, and we'll see you soon. Bye.